question 26 is similar to kind of what we saw in class, where we're told pH. We're looking for the molarity of that acid. So yeah, a little bit different version of what we were looking at in class. So we're told that this solution of HF has a Ka of 7.2 times 10 to the minus 4. Zoe, what's your pH of that solution?
2.21.
And we have a pH of 2.21. So we know, right, our Ka expression is always going to be concentration of hydronium times the conjugate base all over the concentration of our acid. So this is a little bit different in that here, normally we've been given the concentration of the acid. Here, this is what we're finding. We're trying to find what's this concentration of the acid given the pH of the solution and the Ka of that acid. So similar pathway to some of the other problems we looked at in that I have pH. I know I can turn pH into hydronium, and I know my hydronium should also equal the concentration of the conjugate base. So hydronium concentration equals 10 to the negative pH, so 10 to the negative 2.21. Just be careful, right? The pH is a variable, so it'll be different for your question, or it might be different for your question. So negative 2.21. And I get a hydronium concentration of 6.17 times 10 to the minus 3 molar. Now I can plug that in to the Ka expression because I know hydronium, right? That should equal the concentration of the conjugate base as well. So Ka of 7.2 times 10 to the minus 4 equals hydronium 6.17 times 10 to the minus 3. Conjugate base 6.17 times 10 to the minus 3. And now here is our X. We don't know the concentrations. So I'm going to square those, going to multiply the X across. So I get that squared. Multiply X across. So I get 7.2 times 10 to the minus 4. X equals 3.8 times 10 to the minus 5. Divide both sides by that 7.2 times 10 to the minus 4. Right, and 7.2 times 10 to the minus 4. I get a concentration of X of approximately, 5.3 times 10 to the minus 2 molar, so 0.053 molar. Again, your number, your concentration might be slightly different if your pH was a little bit different. So again, that's a variable here. So the steps would be the same though. You're going to plug your pH in, find the hydronium concentration. You're going to square that because it's the same as your conjugate base concentration. Multiplied the X across, and then just divided both sides by the 7.2 times 10 to the minus 4 to get X by itself. X was our initial concentration of that HF. So just a slight variation on some of the problems we did in class.